Think about every time you bought something online before 2008. Every single transaction had a massive, glaring flaw. You literally couldn't move a digital penny without some bank or corporation standing right in the middle, taking their cut and logging all your data. We all just kind of accepted this massive blind spot, right? It was just the cost of doing business on the internet. But then, in 2008, a completely silent, cryptographic revolution challenged the entire foundation of how we handle digital commerce.
Enter Satoshi Nakamoto. Now, whether you follow crypto or not, Satoshi pointed out something we were all blindly accepting: the massive, hidden costs of relying on a central authority. Think about it. In a purely digital world, if I send you a digital coin, what's actually stopping me from copying and pasting that exact same file to someone else? That's the classic double spending problem. To stop it, we've always used banks as trusted third parties to hold the ledger. But here's the catch. That trust-based model means disputes are totally unavoidable, mediation costs skyrocket, and making small, casual transactions completely impractical. The constant need for trust literally spreads friction through the entire system.
So this naturally leads to one really dangerous, provocative question. What if we simply didn't need them? What if two willing people could just transact directly, without any third party mediating the exchange? Well, to pull that off, we'd have to completely abandon blind trust and replace it with hard cryptographic proof.
And this shift, it didn't just disrupt finance. Building a purely peer-to-peer electronic system actually laid the groundwork to completely overhaul the physical world too. We're talking about everything from the underlying architecture of the internet itself, all the way to the massive, complex global supply chains moving goods across our oceans every single day. Let's strip away the hype for a second and look at the actual tech. At its core, the solution proposed back in 2008 relies on distributed ledger technology, or DLT. You might also hear it called replicated journal technology, mostly because it acts a lot like an ongoing chronological journal of events. The absolute fundamental concept here is decentralized consensus. It's a system that allows digital data to be perfectly copied, shared, and synchronized across thousands of different computers worldwide, completely without a single central administrator calling the shots.
To really picture this, think about how we usually share data today. Like if you and your team are using a standard shared text document in the cloud, anyone with editing rights can, either accidentally or maliciously, just delete the whole file. Or they can go back and alter past entries. A distributed ledger, however, operates under incredibly strict cryptographic rules. You can only ever append new data. You cannot ever delete or change what has already been recorded. Once it's in that ledger, it is permanently etched into history. No takebacks.
Okay, so let's quickly map out how this process actually works in practice. When a transaction happens, it's instantly broadcast to the peer-to-peer network. The computers on the network, the nodes, collect these transactions into a block. But before that block is accepted as the absolute truth, these nodes have to execute a proof of work. This means they're using massive amounts of CPU power to solve a highly complex cryptographic puzzle. The very first node to solve it broadcasts the block to everyone else. The network verifies it, and then, here's the magic, they chain that block to the previous one using a cryptographic hash. So to alter a past block, an attacker would literally have to redo the proof of work for that block, plus every single block chained after it, all while somehow outpacing the entire honest network. It basically becomes computationally impossible.
This massive shift from centralized trust to decentralized cryptographic proof created a huge digital ripple effect. It's shifting the very architecture of the internet away from centralized monopolies. Think of the progression. We started with Web 1, which was basically just static HTML pages giving us a simple, one-way reading experience. Then came Web 2, which is the interactive web we're all using right now, heavily dominated by centralized tech giants who facilitate our interactions but ultimately control our user-generated data. And now, blockchain is ushering in Web 3. This is a decentralized internet where users actually own their data, which paves the way for a unified metaverse. So what does this decentralized architecture actually look like? Well, Web 3 connects the Internet of Things, integrating AR and VR to build unified digital environments. It utilizes utility tokens for seamless, borderless payments, and crucially, it introduces NFTs, or non-fungible tokens. Forget the hype around digital art for a second. At their core, NFTs act as cryptographic verification of your identity and your true digital ownership. They allow you to prove you own an asset online without giving up control of your personal data to some centralized platform.
Now, all of this sounds incredible for the digital realm, right? Digital cash, unified metaverses, absolute digital ownership. But as an explainer of this technology, we have to ask the really practical question. How on earth does an immutable digital ledger actually apply to the messy, unpredictable physical world we live in? To answer that, let's look at global supply chains. Traditional logistics are honestly a mess. They are plagued by lost documents, totally opaque product origins, and endless manual errors that cause huge delays in transit. But when you apply a blockchain to logistics, you suddenly get a permanent, unalterable history for physical products. Imagine integrating tiny sensors into shipping containers. Those sensors write data directly to the blockchain, giving us real-time tracking of not just location, but even physical conditions, like if the temperature inside a refrigerated container deviates by even a single degree. The immutable nature of the ledger perfectly solves the absolute worst pain points of modern physical shipping.
Now, what's really interesting here is the sheer scale of the inefficiency we currently just accept. It is staggering. Did you know a simple shipment of frozen goods from East Africa to Europe requires the involvement of about 30 different people in over 200 separate interactions? It's a total bureaucratic nightmare. The cost of just processing the trade-related paperwork can make up 15 to 50% of the total transport cost. No way, right? That staggering cost of trust is exactly why Maersk, the world's largest shipping company, actually partnered with IBM. They teamed up to digitize the tracking of 10 million shipping containers using blockchain, with the goal of turning literal mountains of complex paperwork into highly efficient, instantly verified digital records.
Blockchain tackles this logistical mess using 4 vital pillars. First, you get transparency, meaning everyone involved shares the exact same single source of truth. Then, authentication, which definitively proves the origin and integrity of the goods and the equipment. Third is automation, which absolutely crushes manual bottlenecks. And finally, tokenization, which allows real physical assets to be represented and traded digitally. These 4 features directly enhance how every single member of a supply chain integrates and coordinates with one another.
In practice, these pillars completely transform day-to-day operations. By sharing that real-time IoT sensor data, we gain incredible supply chain visibility. This prevents what's called the bullwhip effect, where a tiny blind spot early on causes massive disruptions down the line. We also get supply chain integrity through immutable origin tracing, basically certifying authenticity and massively reducing fraud. Then there's orchestration. This is where smart contracts come in. They're essentially self-executing code on the blockchain that allows logistics to operate fluidly and automatically based on preset rules. And finally, virtualization, which optimizes our physical infrastructure and software resources to ensure maximum flexibility across the entire supply chain.
Now, you might be wondering, do giant global corporations really want all their shipping routes or financial data broadcast on a public network for anyone to see? Well, no, not necessarily. And this brings us to a really vital distinction. Yes, there are public chains like Bitcoin, which are open to anyone and completely decentralized. But businesses can also build private chains. These are restricted access networks specifically tailored for enterprise ecosystems. So organizations can maintain strict privacy over their sensitive business operations while still reaping all the efficiency, orchestration, and security benefits that a blockchain provides.
But look, here is the reality check. The technology absolutely works. The cryptographic proof is incredibly solid, and the smart contracts execute flawlessly. But the true key to unlocking blockchain at a massive global scale isn't just about writing better code. It's about building a unified culture of collaboration. If this is going to truly revolutionize global infrastructure, we need governments, fiercely competitive businesses, and international regulators to actually sit down and agree on shared standards. The tech is completely ready to go, but the human element, actually convincing thousands of fiercely independent entities to cooperate within a shared ecosystem, that remains our absolute biggest hurdle. The evolution of this technology brings immense promise, but also staggering regulatory complexity. We are literally trying to rewire the trust mechanisms of the entire planet here. So, as we wrap up this explainer, I want to leave you to ponder this. Will the immense effort, the high costs, and the complex regulations required to align all these global players ultimately outweigh the promise of a completely trustless society? Keep questioning the systems you rely on every day.